The standard way to convert from the given form into the form that's asked for in part A is to first of all rearrange the given expression so that we have our x's together and our y's together. And then we can pop the 25 onto the other side by subtraction. And then effectively we complete the square on the x part and the y part. So that will give us x minus 5 squared, and then we take away the extra 5 squared that we get, and then we have y plus 7 squared and take away the extra 7 squared that we get. And that gives us x minus 5 squared plus y plus 7 squared equals minus 25 plus 25, which is the 5 squared, plus 49, which is the 7 squared, and that's therefore 49. So that means we have A is 5, B is minus 7, and K is 49. Now, there is another way of doing part A, and that is to compare coefficients. So, if we write out the expression we've been given, and that's going to be equivalent to the x minus a squared plus y minus b squared take away k. So that was making the x minus a squared form into an equals naught. Now if we then open up those brackets, we get x squared minus 2ax plus a squared plus y squared minus 2by plus b squared take away k. And this is where we get that the minus 10 is the coefficient of x and minus 2a is the coefficient of x. So that allows us to say, because this is an equivalence, meaning it's true for all values of x and y, then that means each separate bit has to be equal. So we have minus 10 is minus 2a, so a is 5. From the, looking at the plus 14y, must be minus 2b, so that gives us 14 equals minus 2b, which means that b is minus 7. And then for the constant, we've got 25. In fact, I will change colours here and use blue. So we have the blue there, and that's those 3 bits. So that means that 25 is equal to a squared plus b squared minus k. So we have that k is a squared plus b squared minus 25. So that's 5 squared plus 7 squared minus 25, which is again 49. So if you were struggling with completing the square, perhaps in an examination stress position, then you can always try and do the comparing coefficients method. So hence for the circle, part B, write down the coordinates of its centre. Well, we'll have a look at this a bit later on, but essentially in this situation, when we have x minus a squared plus y minus b squared equals k, we actually very often would write equals r squared. And then we have that the centre, which is what's being asked for in part I, is just given by a comma b, and the radius is given by r, and since r squared is equal to k, which in this case is 49, that gives us r equals 7. Oh, and I should have said that AB, of course, in this case, if we go over to here, that tells us that AB is 5, comma, minus 7. Now for sketching the circle, there's different ways of doing this, but one thing I find is that if I try to draw a circle having established what the radius and the centre are, I draw a sort of terrible sort of thing like that. So I'll get rid of that, and what I will do is draw a circle, which is not too difficult to do as long as you haven't got to fit it to anything, and then I'll put my axes in. Now, this point here, the y coordinate is minus 7 and the radius is 7, which means that that must be where y equals 0, or the x-axis is. So that's because that distance there is 7, and this coordinate is 5 minus 7. Now that also means that if we go across here, we've also got 7, so we just need to not quite get there, and then we can put the y-axis in there. So that's our sketch, and we should note that that is the coordinate 5. Okay, so that's C part I, and then we've got part II. Write down the coordinates of the point on C that is furthest away from the x-axis. Well, this is the x-axis here, so this is the point right down at the bottom here, and all we've done there is gone another 7 down from the centre, so that point is going to be 5 minus 7, and then we're taking 7 away from the y coordinate, so that gives us 5 minus 14. It's worth knowing how the equation of the circle arises, or where we can get it from. There are different ways of doing this, but one way is to look at the unit circle to start with, and that's the circle that's centred on 0, 0 and has a radius of 1, which we can see here. And this allows us to say that for any point on the circle we have x squared plus y squared is 1, and the way we do this is to apply Pythagoras to it. So r, the radius, is always going to be 1 for the unit circle, obviously, and then we have our delta x, or the change of x, and then the change of y. And here we can see that calculation for the point as it stands, and we know from Pythagoras that always this squared, the delta y squared plus the delta x squared, is going to equal the r squared. And if we just move that point round, we can see that happening in the calculation in green. Okay, so that sort of establishes the basic idea of it being a sort of Pythagoras situation. So the next thing is, if we zoom out a bit, and move that calculation out of the way, both calculations out of the way in fact, then we can change the radius. So if we make the radius into 2, and then in this position, funnily enough, it's at 45 degrees, so delta x and delta y are the same, square root of 2, so we get square root of 2 squared is 2, and so on, and that works fine as we would expect. And again, we can move it around. So we're happy now, hopefully, with x squared plus y squared equals r squared, and that means we can forget about that calculation. Now, what if we move the centre? Well, if we change the value of the x coordinate of the centre of the circle, then we are going to be sliding the circle along. And in fact, if you think of the formula being x minus a squared, we are looking at this sort of situation. And as you will know from graph transformations, when we subtract from the x, it moves the graph to the right. Essentially what's happening, or another way of looking at it, is that it moves the axis to the left. So the minus is telling us what's happening to the axis. There is some consideration of this in June 18, Unit 1, Question 5, the video for that. If we think about moving the centre of the circle up or down, then we're changing it in the y direction. And a similar thing happens to transformations in the x direction. So if we increase the value of b, so that this is the y minus b, then it moves up, which is a similar idea. Just move that down so we can see it, to what happens with the f. When we transform to y minus b, the object moves upwards even though it says minus b, and another way of thinking of that is that the axis is moving downwards according to the minus b. Now if we now bring in the calculation box in green, we've added another line there, because the change in x is actually the x coordinate of a, take away the little a that we have. So for the x value that's 1, the centre, and for the change in y we have the y value of a, take away the height of the centre, which is of course our little b, and so delta x becomes x minus a, delta y becomes y minus b, and then we again can see the Pythagoras situation, but this time with the centre not at 0.